Hello everyone and welcome to my latest stream. So I've been kind of slacking lately with the streaming. I'll admit it, I've been trying to do Monday, Wednesday, and possibly Friday. Unfortunately, this fire season has been brutal, so pretty much when I get off work, pager starts going off, going to fires. But the weather cooled down a little bit today. I think it's going to be okay. And today we're going to do something cool. So you're going to want to tune into this. You're going to want to stick around. What I'm going to do is build an Azure function, and it's going to be a basic web API. So basically, I'm going to turn this Azure function into a web API with CRUD actions, and we're going to have in-memory database, I think. And then I'm going to build a Blazor app that interacts with that. And we're going to tie it all together. And it's going to be awesome. So you'll definitely want to stay tuned. And if you're watching this on Twitter or YouTube or LinkedIn, please follow me on Twitch, because Twitch is where I'm going to do the majority of my streams. I'm going to start streaming everything to Twitch, and then sometimes Twitter, sometimes YouTube, etc. So if you want to catch all of my streams, this is the place to do it. So, without further ado, we're going to get started. And the first thing I'm going to need to do here, after I bring up my chat window, of course, one of the first things I want to do is go into Azure and create a new function. So if you don't know what Azure Functions are, they're really cool. They're basically like AWS Lambdas, things like that. It's actually just a very small section of an application that's hosted on Azure. It's very cool. You don't have to do any configuration. You don't have to do all of the things that you usually do with a .NET application. So if you're building a .NET Web API, there's a lot of setup involved. This takes away all that setup. However, it's not an exact replacement for a .NET API. It's good for small things. I mean, that's why it's called Azure Functions. It's good for like functions and methods of things. Wouldn't necessarily recommend it for an entire application, but we're going to build one today. Okay, I'm going to bring up my chat here. All right, perfect. And if my connection is unstable or goofy, please let me know. Twitch is saying that it is, so I'm a little leery about that. So I'm here at my Azure portal, and what I'm going to do is create a function app. For my resource group, you select whatever resource group you want. I have a resource group named Streaming so that I can do Azure stuff on streaming and destroy it. Now, I already have a Turkey Time app, so I'm going to call this Turkey Time app. Oh, Turkey Time app is taken. How about Turkey function? There we go. Now here I can select a runtime stack. I want this to be .NET. We're going to go version 3.1 in the West US, which is where I am. So as you can see here, very simple to create a function app. You've got some details here. This instance details basically will create the URL. And hello, onus on you. Thank you for joining me. What's going on? Got our first person in the chat here. Very cool. So you can select different runtime stacks. So Azure Functions don't have to be written in C#. We're going to do that today. But as you can see here, you can do Node.js, Python, Java, PowerShell Core, etc., which is cool. These things are just awesome. And then you can do a runtime. The only runtime available right now is 3.1. .NET 5, I think, should be available around release time, I'm hoping. And you can do, storage account with it. Set up monitoring if you really want to. And this is going to be our function app. So we'll go ahead and create it. Everything looks good here. And this seems like this interface has changed a few times since I started doing this, but that's okay. All right, deployment in progress. While we're doing that, let's create a new function app here in Visual Studio. So we'll go to create new project. We're going to do this from brand spanking new. And we just search for function. And there's our Azure Functions template. And this template will create an Azure function for us. It's basically a class library. I'm just going to call this function app 1. I don't know why it always tries to go source repos, but we'll create it in repos, place project and solution in the same directory. Now here you've got different kinds of Azure functions that you can create. So what I'm creating today is just a small piece of what you can do with Azure Functions. You can have these things triggered by a timer, as you can see here, a queue, a blob trigger, all these different things can trigger this function. So you could, create like a Cosmos DB trigger when something's inserted, we will do this thing, etc. It's pretty cool. I'm going to create an HTTP trigger here, which just means that every time an HTTP request comes in to this function, it's going to trigger it. I'm going to set my authorization level to anonymous. If you're creating a real app, like a production app, you'll want to put in some authorization in here. Today, I'm just going to do anonymous. It'll be fine. All right. Now, once this thing loads up, we'll run it because it kind of scaffolds out a sample function here named function1, all of this stuff. And I'll kind of explain for those of you, because the whole point of doing this is to teach folks who are curious about Azure Functions how they work. So I will kind of go through this code the first time we create a method, and then we'll go on. For now, I'll just press play. And let's see what comes up. Cool. Our function came up. It accepts get and post at the following URL. So let's load up this URL and let's see what it does. There we go. This HTTP triggered function executed successfully. Pass a name in the query string or in the request body for a personalized response. So it says name. We'll do Jeremy. As you can see by my history, I've done this before. It says, hello, Jeremy. This HTTP triggered executed successfully. Awesome. So we can go ahead and stop it now. And then I'll just kind of explain what produced that message here. Something really quick. Okay. Just making sure that stream was up. It no longer says unstable, so that's awesome. So what I'm going to do is we're going to create another iteration of that Turkey Time app. That's the one that I was working on sometime a couple weeks ago. I'm going to use that as an example here, and that's where we have a family gathering and everybody can put in what food they're going to bring, their name, whether it's gluten-free or vegetarian or not. So that's the demo that we're going to do here today. Now, get some ice water because it's still hot here in Oregon. There's clouds out there, but it's hot, and so I'm still a little dried out. So today's drink of choice, ice water with lemon. Pretty standard for me. I'm not one of those folks that drinks alcohol on stream because I think that would be really dangerous. I think by the end of the stream I may not be doing so well, so water it is. Okay, so we have this here, and we have a public static class, so it's basically a class library here, and we have a decorator that says function name, the name of the function, which is function1. And then we have run as our method name, and passed into run is going to be that HTTP trigger, right? Our authorization level that we set earlier. And these are the methods that it will accept. So as you've probably gathered, we're basically building an API here. Just like a .NET Web API type thing, except a lot less code, a lot less setup with this than there would be for a Web API, which is the whole point of why I'm showing you this. So you can pass get or post methods to this, and then the route is null. We'll work on the route as as we build this out. And then you're passing in the HTTP request object, mainly because you'll need to access that to grab query parameters and things like that. And then we pass in iLogger log, and we'll do that with the ones we build too. I'm going to delete this after I explain it, and we'll create new ones. But let's see, and then we have log information, string name. We're going to request name out of there, and then request body. It does that read to end async on the body, and then we deserialize that into data. You know, and it does a little check here if it exists. If it doesn't exist, we don't do anything. But if it does exist, we'll say hello name. So this is what will go if the string is null or empty, and this is what will go display if it's good. And this string response message is just a string, and it gets sent back as an OK object result, which generates a 200 with this response message in the body. So pretty simple, pretty cool. Let's build another one. Let's see if I remember what I named this last time I did this demo. So we'll do a new Azure function. We're going to just call this food item. And here we go, new Azure function. As you can see, we have all these different kinds of functions. We're going to do an HTTP trigger with an authorization level of anonymous again. And now we have a food item one that is essentially the same as this function one that we're going to delete. And I'm going to check the chat for questions here. Okay, cool. No questions yet. So, and actually in here it brings up this host.json. Now that it's bringing this up, I'm going to add something to it so that we can kind of bypass the CORS stuff. If I remember, it's host, oops, comma, and we want to set our CORS to star. And I think it needs to go here, actually. Yeah, I think it's... Oh, no, it shouldn't go in there. So I don't know why this thing is barking at me like it is. There we go. Perfect. So it object shouldn't contain additional properties. I'm not sure why it's getting that message, because I do need to put this in for CORS purposes. So let's run it really quick, make sure it runs. Yep, looks like it runs. Because, yeah, it shouldn't go in within logging. Oh, this is in host.json. That's why it's a problem. It's not supposed to be in host.json. It's local settings JSON. Okay, and then we're going to have to do this with our Azure function also. There's a couple little tricks you have to do to the function once it hits Azure in order to make this work properly, and we're going to cover that. So, we've got our food item CS, and actually I'm going to refactor this. Because I'm going to create something called food item, so I'm going to rename this food item list. Yes. Perfect. So now this is food item list, because I need to create some models in here and I need to create a model for food items, and I'm going to call that food items. So that's why I had to rename this temporarily. So actually, let's create that. Add new folder, models, and it's just going to be a Poco here. Plain old class object named food item. Sweet. We need to make this public. And then we need to, let's see, string ID. What I'm going to do is, I'm going to use a GUID for an ID. So we'll do public string, and then we'll do GUID, new GUID. Whoops. That way, if nothing is inserted to it, it's going to generate a GUID for us. So that'll be good for creating new, when we create new food items, we don't have to create a new GUID every time for it. It'll create automatically if we don't pass it. So then I need to do string of name. That's going to be the name of the food that we're bringing. We'll do a string for person. So this is going to be an extremely simple data set here. I wish it would quit adding all those spaces, which I'm actually going to need in a minute anyway. Oh, and then a public bool for vegetarian. And we're going to do a bool for gluten-free. Now, one of the things we need to do is we're going to have to convert this into JSON. So I'll put some decorators on here because, as you know, JSON, the naming convention that we have here in C# won't really work in JSON. We want our JSON to be all lowercase. So what we're going to do is do JSON property in Newtonsoft JSON. We're going to say property name for this one is ID. And I'll just add these decorators to each of these properties just to make sure that JSON is lowercase when it comes through. All right, and this is going to be our model here. It should be good to go, and we can, what is it suggesting? Oh, rename, I named that one wrong. Okay, now we've got the C# naming conventions, plus we have some decorators on there from Newtonsoft, and this is all built in, that will lowercase all of those names when this comes out as JSON, which will be pretty handy when we start passing this data back and forth, which we will. So I'll go ahead and save this. Our food item. And then we're going to need a store. So I mentioned that I'll do this in memory. So I'm just going to create a simple in-memory store here. Another plain old class object. We're going to call this food item store. Public static list of food item, just as kind of as simple as it gets. We're going to call that food items. New list of food item. So this will exist in memory as long as that function is up. This food items list will be our list of food items that we go through and add and subtract things to. So we're good. It doesn't like my naming. It looks like ReSharper doesn't like my naming, so try to get rid of that ReSharper error. So we have our food item. We have our food item list. Perfect. Our in-memory database will be rocking and rolling. So what do I need to do next? We'll create our function. So, you mix up functions and methods, and it gets even more confusing when we're talking about Azure Functions, right? Because you have functions in a language, and most of the time those functions are methods, like in C#. Those functions are methods, and then you have Azure Functions, which is the name of this service that we're using. So it gets a little muddy and weird. But this is our Azure Function app, and we're working on a function within that app. So that makes it clear as mud. So we're going to keep this as a public static async, and we're just going to return that iAction result. Instead of run, I'll name this something else. I'll name this method get food items, which I'll name it up here the same so that it's consistent. All right. Now in get food items, we have to pass in that trigger. So we'll do HTTP trigger. And now we can pass in this trigger. There's our authorization level again. We could change it here if we'd like to, but we're not going to. And then the methods that it's going to accept. This one's going to accept get at a minimum. And then our route needs to be specified. So our route is, just like traditional API language, the route is the URL that's going to bring this up. Our URL, I think, should be just food item. And as you'll see, once we press play and move, it's going to be /API/food item. So the next thing we pass in here is our request, our HTTP request, which I can never say properly for some reason. And then we'll pass in our iLogger. iLogger of log. And now we can get to the body of our function. And I can see I got a little typo here for how I was supposed to set that up. Okay, so now we're passing in that trigger, we're passing in the request, and we're passing in a logger. All of those things are required for this function. So for this, we'll do a log. We'll log information and say get food items called with get. Just to kind of make it clear that we're allowing a get for this. So that's the only request that's ever going to get is a get request. And then for this, we'll just return new OK object result, and it's going to be food item store, food items. So in other words, nothing right now, right? Like if we press play. By the way, a lot of people like to say F5, but when I was a developer and talking to people, I would just tell them push play, push play, push play. So now I just say push play. I know it's F5, I know it's run, but I like to just say push play. There we go. So we get nothing out of this first request here. This API food item returns nothing, which is what we want for now. And this is going to be our get method that's going to retrieve the list of food items once we put food items in there. Quick check for questions. No questions so far. Right on. So now I'm just going to copy and paste this just to save time. And we'll call this one get food items by ID. We'll change that method name. Now it's an entirely different method. Get food items called, we'll say by ID called with get. Cool. So now we gotta do things a little different here. So the way this works is we're going to get a food item by ID. So once we have a list of food items, each of those is going to have a GUID for an ID. We want to be able to extract just one of those items by that GUID, by that ID. So in order to do that, the first thing we need to do is change our route. So we can pass that ID in through the URL. And then we need to capture it. We can capture it here. I like to put my logger at the end. That's just a personal preference, but we're just going to pass in a string of ID. And then that's going to be bound to this ID that comes in the URL. So get food items ID called with get. Should be, that's a pretty accurate message. So for this, we just use a little link to grab this. And, you know, in a regular application with a database, this probably wouldn't be how you do it, but this is great for demonstrating purposes. We want to just we just want to get a food item. And that food item, of course, is going to be from the food item store. Food items. And we're going to say first or default. And we'll say FID equals ID. So if, you know, we're going to pass in this ID as a string, it can be any string in the world. But if that string happens to match one of those GUIDs, then we're going to get a food item object right here. So we'll say if food item is null, that means we didn't get any food items out of the database. And we'll return a 404, which will be not found result. So it's pretty straightforward. Else, we're just going to return that food item. So actually, we don't even need an else. We'll just put it here and say return new object OK result of food item. And I will definitely demonstrate this when we get a little more functionality, but this is going to be our second method here, where we just grab this by ID. Now you'll notice it's an async task. We're not using await yet for this, but we're just passing these back. This is all pretty synchronous stuff for the most part. And the next thing we need, what's the next thing we need? Delete a food item or add a food item. That's what we need to do. We need to add a food item. And you'll notice there's a couple of different design decisions that I'm making here. So I'll stop for a second and talk about this. You can build Azure Functions and have one method per function in the application. What I'm doing is grouping these intentionally so that each of these routes, you know, I want this route to be something that I can send a GET request to, and it's going to know if it's a GET to dump out all the food items. If I send a GET with a specific ID, it's going to dump a food item of that ID. Then if you send it a post, it's going to create one. If you send it a delete request, all to the same URL, I want them all to be bound within the same URL and be switched by URL parameters and methods that are being sent. So for organization purposes, I want everything that's food item related right here in this food item list.cs. But you don't have to do it that way. You can take each of these methods, put them in their own separate application. That might actually work better for you in certain cases where if you have a lot going on, you've got a lot of big things, you might want to break this out and say food item list get, food item list post, food item add food item, all of these different things you can do. I'm deciding not to right now. So I'm going to call this add food item because that's what it's going to do. And we'll name it add food item. And this one's going to look a little bit different from the previous ones. For one thing, it's going to take a post. So we've got that same route. but this is going to take a post. We're going to pass in that HTTP request like we do with all of them. Check this message on my phone here. Okay. So this is going to take a post. So if the Azure function sees that post coming in, then it's going to know, okay, this is probably add food item, and it's going to route it there. You can make it more complex and confusing, but I'm trying to keep it as simple as possible. So for this one, we'll say add food item called. With post. And you don't even need to put these in. This is really just for our purposes so we can watch and see what's going on, but you can log things however you want. So what we need to do is grab, so we know we're sending a post, right? So we need to grab something out of the body of that post. Hopefully, ideally, what's going to be in that body of the post is JSON that matches up with our model here, which you remember is fooditem.cs. So hopefully somebody is sending, in the body of a post, they're sending JSON that matches up with this. If they're not, that's a problem, and you can create handlers right in here in this method for that problem. I'm going to keep it pretty simple today and just say string. We'll get the request body. And this probably looks familiar to anyone that's done like API stuff before. We're just going to use a stream reader. We're going to say stream reader on the request.body, read to end async. We're just going to asynchronously read that body. It could be anything. And that's one of the things that I want to stress if you're going to build production applications with this. That request.body right here is a string that's passed in with a post, and it can be anything. It can be binary. It can be long lists. It could be, you know, a 1 GB string. You never know. So this is something that you definitely want to, in a production application, you want to do some sanitization of this. And so, you know, at a minimum, try to grab that request size, because browsers will limit the size of that request. But if somebody's sending something with curl or something like that, this is just something that you'll want to put a lot of thought into that request body. Right now, I'm just being super trusting and saying everybody's going to send me these JSON files. So we need to deserialize that request. So let's pretend we put if a million different things and we filtered this out. Actually, we'll do string input for that too. And we'll do JSON convert. Deserialize object. That's right. Of food item. Now we're deserializing that object of food item, which of course is going to be our request body up here. So we're assuming that everything is great, that this is always going to be, I suppose that this would help. We're going to assume this is always going to be JSON. And we'll do a var here, so it will make it a food item. I don't know why I was thinking stream, but this is going to deserialize that JSON. It's going to take the JSON in. The JSON is going to be perfect every time somebody sends something to it, right? Of course. And just turn it into a food item. Which then, of course, we need to take food item. We need to create our own food item out of that JSON that's sent in. So our name is going to be input, which is this here, input.name. What did we call that second one? Person. Input.person. The next one's going to be the vegetarian. And then gluten-free. Gluten-free. I can never type when people are watching. I don't know why. Okay, so now we're just taking this, we're deserializing this into a food item. We're creating another food item and grabbing those parameters, or properties, I should say. And we'll just add them to the food item store. So food items, add, we're going to add that food item. Now what we could do for the OK object result is return a list of food items, or we could just, what I think I'll do is I'll just return the food item in the body. So you can see what's created. You'll see the new ID that it gets because we'll send it without an ID, and it'll be great. So now we have an add food item method, which naturally means we need a delete food item method. So for this one, I'm going to copy again our first function and just add to it. I keep checking the chat, make sure I'm not jumping ahead and nobody has questions. So this one will be delete food item. Of course. Delete food item. Once again, I think I'll pass this in through this route. So we'll do an ID. Our method, of course, is going to be delete. So we're going to use an actual delete for this. And then we'll just pass in a string of ID. And then we'll delete based on that ID. Perfecto. So delete food item called with delete. So to do this, we're going to have to grab by ID again. We can just copy and paste. There we go. This little thing here. Our little query. Now we got our food item again. So we're going to delete by ID. So we're going to send it a GUID. If that GUID exists in our in-memory list, then we're going to get a food item. So once again, we'll do if food item null. I guess I could have copied and pasted this as well, right? If food item equals null, we'll return that 404. Otherwise, we're going to return just an OK result. That basically says, hey, okay, we're good to go. So what we have here is we have get food items. We'll get a whole list. We can get them individually. We can add one. We can delete one. I think for our purposes today, this will be perfect. So I'm going to press play. And what we're going to do is we're going to use Postman to do this. Now, look at what it shows here. When you press play, the functions come up. We can see we have an add food item function that accepts post to localhost 7071 API food item, which I will copy that URL. If we want to delete it, we have delete food item that accepts delete and then an ID. Then we have get food items, which is a get that's just going to return a list of food items. And then get food items by ID, which is where you will get a single one. So let's see if this works. First, we'll get food items. We get nothing, right? So remember before we had a post, where if you send a post to it, we'll select raw and then JSON, and we'll just we'll create a food item. Name Jeremy. Oh, name is supposed to be the name of the food item that I'm bringing. I'm bringing hamburgers. Person, Jeremy. Vegetarian, no. And I forgot to lowercase my own JSON here. It's been a long week, he says on Tuesday, and it's not gluten-free. Okay, and I sent this JSON off, and as you can see, we returned, because we wanted to set it in the code so that we return that new object back. It sends back the new object with an ID. Cool. Now we'll run git again, and there's our list. So let's add another one. Let's say I'm also going to bring a salad, since we're living in a fantasy world anyway, right? Actually, I like salads. Oh, I made a mistake. This salad is actually vegetarian and gluten-free. So I'll send that. When I go back to my list, oh, I've got 2 salads. One of them is wrong. So I'll copy this ID. Well, actually, I'll copy the URL first. And then I'll copy this ID. We'll tap it on the end of that URL here. And we'll send it to delete. Cool. We got status of 200 OK. Now let's check our list. And that did not delete. So now we have to figure out why. Oh, I know why. I forgot to put that functionality in here. Testing is important. So in delete food item, I put in here, if the food item is null, return a 404, otherwise return an OK result. Right here, I need to actually delete that. So we'll open up that food item store. Food items dot remove. And then we will remove that food item. Testing is important. I failed a very basic test right there. And Nick Tyndall, thank you for joining. What is the white box before delete? Oh, and delete. I don't think you ever deleted it. You're right. I did not delete it because I forgot to put that in there. So now we're back to 0 again. Let's do this. Let's do this all over again. Hamburgers. Add that. Then I'm going to add my salad. Oops, that's the wrong one. I wanted it to be vegetarian and gluten-free. Oh no, I have 2 salads. What am I going to do? I'm going to take this ID here. And Nick, I'm not sure what you mean by what is the white box before delete. Not sure what you mean by that. I'm going to put in this delete, send it. I get the 200 OK. Go back to the list, and it deletes it. So removes it out of that in-memory database. Now what's cool about this is, say, item. I can just sit here and send these all day. Eventually it will choke out, but I can just keep sending these. And as you can see, it generates a new GUID for each one. Okay, I'll open up Visual Studio here. Oh, some sort of syntax highlighting. Right here it's saying params methods. So this theme I have in Visual Studio is a little weird. I chose this theme because I think it's the most readable. Like I put this theme in and I made it big for presenting like this so that people could read the code. However, the colors are still a little off. I don't know how to modify Visual Studio themes, but I'm going to have to learn it someday because I would like to change. This one's a little weird. Like when you create a new project, some of those screens look a little strange. But yeah, that white box just says that it's a string array of methods. So just to go over this, now that we're done with our function app, we've got get food items by ID, add a food item, delete a food item. Everything is hunky-dory. Okay. So we verified that it works locally. Let's publish it. We'll go to publish function app. Where do we want to publish it to? Well, I want to publish it to Azure. But as you can see, we can do Docker container registry, or you could do a folder. I haven't actually done the Docker registry yet, but or container registry or anything like that, but I'm going to. It's going to be a thing that I do. So now, view resource group. We're going to go streaming turkey function. Publish it, and our site is going to be turkeyfunction.azurewebsites.net. Now, one of the things that I'll need to do here is go to my Azure portal and add in that core's stuff. So go in function app. We called this turkey function. Now in here, you've got some configuration. You've got some different things you can do here. One of the things in the configuration, you got to remember where to go. I do believe there's something that I need to take out of here, but we'll see in a minute. Scroll down to cores, allowed origins, star. Oops. So we got star, which means we can request this thing from anywhere. That being said, let's see if it actually does. This should show me that welcome screen. There we go. Your Functions 3.0 app is up and running. Awesome. So let's go to API. Food items. Cannot be found. So let me go back in here. We've got our cores set up. Website content shared. Function runtime settings. 32-bit. So these should all be good. But for some reason, when I change it, try this. 404 not found. So there is something blocking this, and I do have the local settings JSON, have cores set up there. I'm going to check my other functions app that I used for this demo and see. Turkey time, I believe this one worked, and or was it configuration? I feel like there's something I had to remove from here. Run from package, I believe, is what I have to add in here. Which I checked that box, so that shouldn't be it, but let's try it. Configuration. Oop, it is not in here. So we're going to do website run from package 1. Because this basically deploys it as a zip. Update those settings. Publish it again. Version release. And it's pushing that zip file, so it basically just zips it on your local folder, on a local folder on your machine, zips it up there, then deploys it and unzips it. Waiting for function app ready. And now I think our function app is ready. Oh, and it's just food item, not food items. There we go. So now it works. So as we can see here, we'll copy this part of the URL, and we're getting that blank object there. So let's go back into Postman, and we'll replace localhost with this one. We're getting nothing. Here's our post to create a new one. We'll put that in there. We'll send it a new one. Oh, looks like it gave me a new one. And then we'll copy that one when we want to delete. So now our Azure Functions working. This is again just a web API, you know, simple web API basically. I'm bringing carrots. Mom's gonna bring Colt Cannon, which is not vegetarian or gluten-free. And there we go. Got a nice working API. Now for a production application, you will want to configure cores and other security items, because right now, actually, any of you watching could start sending stuff to this and deleting stuff, which would be a very intense way of heckling somebody, right? But let's delete one, make sure our delete works. Looks like delete works. Oh, nope, that was 404. So let's see what I did wrong. I want to delete this one that just says item. Copy the ID, send it to delete. There we go, there's a 200 OK. So the first item is gone. Cool. So we can delete. So now comes the fun part. Now comes the Blazor part, right? Because I promised Blazor. And what I'm going to do is build a Blazor app that connects with this. So exciting stuff, right? But just to recap, Azure Functions are this super simple, like, let's look at this code really quick. Just super simple code. This is a web API, right? It's not a very good web API. It's not production level API by any means. But it's pretty decent. We're able to add items, delete items, make a list of them, get a specific one. All of that in a very small amount of code here. So it's real lean and mean. And here's what's really cool about these Azure Functions. It's not just the lean and mean part, it's the scaling part. So these things scale automatically. So let's say you're putting together an app and you've got these functions and microservices, as much as I hate to use that term. These are, essentially microservices that are running. You've got all these little API pieces running, and then all of a sudden, Saturday morning when you're not at work, the whole world comes in and starts flooding your website because you've got a big scale. All of these little functions will scale up automatically, and they'll get bigger and stronger based on which ones are being used. So the advantage there is, let's say you've got this old school ASP.NET app, and I say that jokingly because it's still absolutely modern to make ASP.NET apps. But let's say you have an ASP.NET app running under IAS on a traditional VM. That Saturday morning is going to be a little rough for you because you're going to have to make that VM bigger, or you're going to have to duplicate it or something to scale up. It's not going to do it automatically. You're going to have to go in there and do it. And it could just be one function, like one little Azure function, one little API, and you're going to have to upgrade everything around it, where in this case, it's going to be this function's getting hit, it's getting stormed, Azure will scale it out for you. So that's the big advantage is scaling. Like most things in the cloud, Scaling is super important, and not configuring. So if you're wondering, like, what's the deal with cloud native applications or Azure Functions, the big deal is no configuration. You haven't seen me open up IIS or anything like that. So I'm not configuring any servers. I'm not messing with any servers, and scales like wild. So let's create another application here. This is going to be our Blazor app. So we're going to create a new project. And this is going to be a Blazor WebAssembly app. And I'll talk about why Blazor WebAssembly is so freaking cool. And as you can see, I already have the template here, but you can also search for Blazor. There we go, Blazor WebAssembly app. We're going to call it Web Application 1, sure. There we go, and this one we want it to be .NET Core 3.1, no authentication, none of that stuff. We don't even need it to be hosted anywhere. Now this is a WebAssembly app, which means it's going to do everything in WebAssembly. For APIs with authentication, if you're using keys and things like that, you're not going to want to do a WebAssembly. Most likely, you would want to still do a .NET hosted, which the application itself will be virtually the same. It's just going to have a little bit different hosting model. But there is no way right now for a Blazor WebAssembly app to store secrets very well. Somebody who's really crafty, really good, can get your secrets from a WebAssembly app. So we're going to open this up, make sure our Blazor app works, and it does. And I will be right back in just a second. All right, we're back. Okay, and I see something in the chat here. Do you have more details on the secret storage on Blazor? Maybe a problem for us to deal with. So there's two different hosting models with Blazor. One of them is a WebAssembly model and then hosting on a server. With the WebAssembly model, it crafts everything and bundles it all up into WebAssembly. It sends a copy of the .NET framework, believe it or not, in WebAssembly across to the browser. One of the advantages to that model is everything is located within the browser. So you could even run offline. Like you could push a Blazor app out to somebody and it doesn't have to be connected to the internet or connected to your server, and it can run offline. So I think the best application for WebAssembly is probably games. It runs really fast, so WebAssembly is super fast. But storing secrets, I haven't done a ton of research, but from what I know, any secret that you put into that application is going to have to be stored in the browser with WebAssembly and be sent across. So even if you're encrypting it or something like that, it's still going to be stored on the person's computer. So if somebody's really crafty, they can find that. And F9 Analytics, thank you for joining. pretty exciting. So many people here. But it's all going to be on the browser, right? And it's going to be in JavaScript. And if somebody's really crafty, they're going to be able to grab that API key. Whether they can do anything with that API key or not remains to be seen. You know, you don't have to worry about things like authentication as much, but just those API keys, those kinds of secrets, you're going to have to pass it to the API. Now, you can use cores, you can use domain level security and things like that to secure it. So you can basically say, you know, with cores and domain level security that only jeremymorgan.com can access this jeremymorgan.com/API. So somebody can't craft it and do API calls from some other domain, but it's not really ideal. With the server model, then you can store your secrets, you can compile them, you can keep them all on the server, and yeah, it's just a little bit more secure that way. I'm still doing some research on that. Oh, you just built some stuff in WebAssembly. So yeah, that's the only thing you really have to worry about, is those API keys. And if somebody's really crafty, they can get the API key, but you know, maybe they can't do anything with the API key if they don't, you know, if you have a domain level security or something locked in. So we have our little Blazor app here. It's doing fetch data. What I'm going to do is tie this to the API that we just built through Azure Functions. And I just want to show how easy this is. And of course, how much JavaScript you have to write, which is the big appealing thing for me. It's not having to write a lot of JavaScript. I'm going to get rid of this fetch data. I don't need this. I'm going to get rid of the counter. And I'm going to create a new page. I'll probably call this food item list as well. So we'll create a new Razor component here. So if you've never used Blazor before, basically a Razor component is HTML with C# mixed into it. Takes it, compiles it into WebAssembly or into ASP or whatever. But you can mix C# code and HTML, which is awesome. I mean, a lot of the Blazor stuff I've been doing, I just think Blazor is like the way of the future. Especially since with .NET 5, just a little side note, with .NET 5, you're going to be able to deploy anything to any environment. So Windows, Linux, Mac, BSD, whatever. I really think it's going to change the web development game big time. And I'm a Linux guy. Also, you know, I've got one foot in my career, you know, over the last 20 years, I've had one foot in a Linux boat and one foot in a Microsoft boat. I actually worked for an R&D team for years with a Ubuntu 10.04 desktop, and everything on the entire team was Linux because people hated Microsoft so much on that team. Every single thing we did was Linux. Our desktops were Linux. We developed for Linux. We developed software, put it on Linux machines. So, you know, I'm no stranger to Linux, but I don't hate Microsoft or .NET or any of those technologies because I think they're amazing. So I have been really happy the last few years with this .NET Core, which will soon just be .NET, and things like Blazor. Like, I'm really happy with it. And Blazor is just like super exciting to me. I'm really enjoying playing around with Blazor. I think it's another groundbreaking thing. Sometimes Microsoft does things that fly under the radar in the wide community, like TypeScript, for instance. You know, when I first saw TypeScript, I'm like, that's genius. That's beautiful. And everybody ignored it for the longest time. And then all of a sudden the front-end development community was like, holy moly, this is great. And they adopted it. So Microsoft comes up with some good stuff. I don't get a lot of the hate. I also don't listen to it. I don't listen to hate for any tech stuff anymore. There's good and bad in everything. What did I call this? Food item list. So let's make sure our Razor component works. Ta-da, there's our food items. And all of this is going to be contained in one component. with the exception of the models. So we do need to create some models, or a model. We just have to create one. And it's going to look really familiar to you. So this is going to be, oh, we got to create a folder. I like to organize it in a folder. Add new folder. Again, we're doing models. And once again, we're going to do a food item. And it's going to be a plain old class object. We can use records here pretty soon. And that's pretty exciting. But so we have food item.cs. This will look really familiar to you because I'm just going to copy and paste it right out of our function app. JSON properties and everything. Copy. Paste. This one I think I have to install Newtonsoft. It'll bark at me at some point here. There we go. No, not Nest or Bogus. We need Newtonsoft. That's kind of interesting that it's suggesting that. Remember how to spell that. Where's Newtonsoft? Since I don't remember off the top of my head. Yeah, fake, tweet sharp. Super odd that it's not finding Newtonsoft JSON. Maybe I'm just spelling it totally wrong. Why is Newtonsoft better than System Text JSON? It's not. I use both. We could, let's see. System Text JSON. I don't think I can do those same decorators with it though. Well, the remote server returned, package manager console. We'll do install package. I believe it's Newtonsoft.json. There we go. There's our little property attributes. I will use system text JSON further, and I think Newtonsoft JSON might be going away at some point. I think it's so embedded now. Okay, so we got our nav menu, we got our food item list, and then yeah, copied and pasted this directly out of the function app, so we know it's the exact same, basically the exact same object. So our food item list razor. And what do I need to put in here? I want to put in a display message of some type. Not protected prop. And then we're going to loop through the food items. So up here, we can put in a little logic up here. So there's a code section, and that's where all the C# goes. But you can also put, there's also code within the HTML. It's all in Razor syntax. Again, Razor is something that's really cool. I'm not a Razor expert, but I'm gonna create a list here of food items. So I'm gonna say if food items is null, or it's not null. That was almost a really dumb mistake. It's not null. We're going to build out a table. And that food items is going to be a array. So public food item. I should name it that. Get set. So the set's going to work. I'm going to change the music up a little bit. I'm done with this particular list. All right, there we go. Okay, so if the food items list is not null, we're going to create a table to show it off. So I'm going to do table, and it's just going to be a bootstrap type thing. Nothing super fancy. Class table. It really doesn't like my typing today. Table heading. And in here we're going to put in these are going to be different columns. So we're going to have the name of food, I guess is probably the best thing I can call it. Name of food, person bringing it, vegetarian, gluten-free, okay. And then we're going to create another little loop here for each. I'm going to say var food item in food items. So for each food item that's in that list, we're going to display a row. Table row. And you don't have to use tables. I'm old school. I remember when tables were the only thing you could do. Those were terrible days. Okay, and we see here, we say table food item name. I'm just going to put in each of these properties. Food item person. Vegetarian. Gluten-free. So this is going to be my row if we have food items in the table. Now, of course, if I press no, press play, we have no food items in our table, obviously, because food items isn't populated by anything, but I just kind of want to do a quick check, make sure nothing's breaking. We will certainly populate this table later. So we have our food item class. We have our stuff. Let's create a sort of pseudo constructor. Protected override. And we'll say async task. What is, no, man. This thing just went sideways on me. Protected override task. Async task, and it's called on initialized async, I believe. Sounds right. And this will be run in the very beginning. Okay, it's going to run synchronously. Don't care. Welcome. There's our message. So now we got to start doing some some actual real methods. Another helper method that I need to put in here is something to populate the table when we have a table. So let's do that. What I'll probably do is shove this down to the bottom. But we're going to call this populate table, and we're going to use an HTTP client to go out and let's see, HTTP client, new HTTP client, and for this, let's see, let's initialize it this way and say there's our base address. That is going to have to be a new URI, and we'll take it right out of Postman. Keep it simple. This is our base URL. Oops. Excellent typing. Okay, so we're making an HTTP request here to that Azure function that we just built, the API food item. So we'll set up a client with that. We'll set up an HTTP response message and call it response. We'll just initialize that here and now. And then we'll do a response, await, client, get async from that base address. So we don't have to do anything to the address or anything. This should work. Response. I'm wondering why this thing is throwing so many errors at me. Wait can only be used with an async method. Of course. So I'll make it an async method. Okay, there we go. So basically this is going to send out an asynchronous request. It's just going to send out a get to that base address. So it's going to be the exact equivalent of what we built right here in Postman. And as you can see, if we send it with Postman, we'll see if that function went to sleep or not. It may have went to sleep. It did. So all our stuff is gone. But that only applies to in-memory databases. So not a big deal. But it did fall asleep. They fall asleep kind of like a lot of these services tend to do. So if response content is an object, and response content, what is it, headers, check to make sure it's we want to check to make sure it's JSON before we start using it. So content type, and I believe it's media type. So this is just making sure that if we got a response of an object and the content media type is application JSON, this is a pretty important one to do because it's going to return back a string that could be in any kind of weird fashion. So Blazor is going to want that to be pretty JSON because we're gonna deserialize it again. So content is going to be response dot content read as string async, not as byte array. Read as string async. So for our content, we're just going to read in content as an asynchronous string. So it's just going to come blazing in as a string, and then we'll have to deserialize that. The way we can do that is we can just assign it to food items. We'll use JSON serializer. We can use JSON serializer in each of Newtonsoft or Systems Text JSON. Either one will work. Deserialize, that into a food item array. So basically, whatever this get request does, so we have this list. We have an array of food items in Blazor, and it kind of sits there. Whatever comes back from this get request is going to wipe all that out and replace it with this list here. So this populate table, we'll call it, every time we do something to make sure that it's updated and that the list that's in Blazor is updated also. So it's food item array. We want to pass in content. This code almost writes itself here. New JSON serializer options. For that, we actually don't need to put in anything here because we did one of the things I usually put in here is like property name, case insensitive. Just in case. Even though we did assign those properties, we put the decorators on the properties to ensure that they're all lowercase, but this is just kind of another quick check. I got one too many of those on there. There we go. So this will populate the table. We actually don't need to do anything else here. And we'll test it out for sure. But for populate table, we want to do that right away. So we'll say populate table. And let's press play. But ideally, this should go make a request to our Azure Function app, grab that list, crunch it all, put it all back into something that Azure can, or Blazor can read. And yeah, I totally borked this up, didn't I? JSON serializer options. That doesn't need to be there at all. Now let's press play. Food items, we've got nothing there. Let's send a couple. And then we'll check our Blazor app. And still not seeing anything yet. So we should be seeing this. So I'm going to have to do a little debugging to find out why that's happening. All right, well, let's see. So I got it bound. System text JSON. I think I need a MIME type. No, that one's a media type. I bet you it's this right here. It's not HTTPS, I've noticed. So let's try that again. Nope. Look at my console here. Food items equals JSerializer. Content null. Response unable to evaluate. So but it did reach this point. Let's see what the content is. Byte stream. Yes, it's not reading that content for some reason. So HTTP client, new HTTP client, base address. It's Turkey function. Let's make sure that this is correct, because this one is returning. Let's see, this probably should be HTTPS anyway, right? Okay. So response is null. We're doing a client get async from that. I think objective is application JSON. Maybe it's actually in my display up here. Food items, food items. Make sure all of these are the same. Showing loading. So am I calling populate table? Oh yeah. Await that for it to work. Oops. There we go. So apparently it's my first day using asynchronous methods. But here we have the two items here. These are great. We will delete one. With our delete method. Oops, I always do that with Postman. Okay, now we've deleted one. Now we should only have one. Back to our Blazor app. Now we only have one. Let's put some, we'll put several items in here just to kind of give it some real looking data. I'm gonna post. And I'm just gonna fill a bunch of these. Hamburgers for me. Potato salad. Now we've got a few items here that we can look at, so that's perfect. And you can see we have the values displayed there as they should be. So let's build some stuff to modify this so I don't have to use Postman. Obviously, we want to use Blazor. So populate tables done. Stash that away. Next method should probably be, let's see, we need a way to add food items. That's what we need. So we can put that here. Put in label, your name. We'll put in labels for each of these things. Or food, we'll say food that you're bringing. Name. That'll probably be good just like that. Food, name, vegetarian, question mark. Gluten-free, question mark. And then we need to put some inputs in here. So for this, input is just text. We'll bind it. Nope, just bind. Bind. Yeah, there we go. Oh, it's going to be going to do that to me. And we're going to bind this to a food item name, which we're going to need to create. You can see here we can create a property, but we need to put these down here. And this is going to be very similar to our model, right? So it's a prop, string name, person bringing it. Oh yeah, we probably can't do that. Probably gonna have a naming collision. So we'll say food item name, food item person, vegetarian, gluten-free. This is what we'll bind this to just for these input items. That's the only thing these are going to do is be bound for input items. Take this. It's going to be food item person. Right, I believe we called it. Yep. And then we need to create a checkbox. So input type checkbox, and we're going to bind that to food item vegetarian. So the way the binding works is one of my favorite things about Blazor. Is we've now bound a bunch of input boxes here to those properties in C#. And this is all C#. That's probably the greatest part of it all, is it's still all C#. So we have food, name, vegetarian, gluten-free. And these are all going to be bound to those properties that I created down below. So I do feel like I should probably put some breaks in here. Make that look a little better. There we go. So we're going to add this. And I'm going to stop for a second because I forgot to mention it in this whole time that I've been streaming, that when I reach 500 followers, I'm going to give away one of these, Raspberry Pi 400. So if you go to my Twitter page, www.twitter.com/JeremyCMorgan, and at the very top there's a tweet. If you retweet that tweet and then follow me on Twitch, as soon as I win $500, or $500, as soon as I get 500 followers, I'm going to send out one of these, or maybe two of these. I don't know. But that'll happen as soon as I reach 500 followers. So retweet that tweet to be entered. What I'm going to do is just take that list of everybody that's retweeted it. We're going to put it into some kind of randomizer program that I find on the internet and do it live. And so if you retweeted that on Twitter and you're following me here on Twitch at 500 followers, we'll do that. So if you retweet that tweet, I'll get more followers and I'll reach 500 faster, and you might get your Raspberry Pi 400 faster. It's a cool little contest I'm doing. I'm pretty excited about it. Now we need to make a method to add these. So we have these, and these inputs that I just showed on the screen are bound to these right here, these four. So what we need to do is we need to make a way to add a food item. So we'll do another task, add food item. Now we've got a food item task. This is what we'll put in this little button up here that we're going to make. We're going to say button, type, submit. When we click it, it's going to bind to this. So this binding in Blazor is just super impressive to me. I'll put add food item. So now we're binding these. Each of these input fields are bound to the properties of the object that we created right down here. And then on our button type, we're binding the onClick event to add food item. So that add food item can grab these out of these properties. It can grab that data out of those properties that are bound to those input boxes, crunch them all together, and turn it into a food item, send it to our Azure function, and add a food item. Really cool how Blazor works, to me. So we're going to do the HTTP client again. Client. We could just take the old one, right? HTTP response. We're going to null that out. And what we need to do is create a JSON payload that we can send in a post to our Azure function to create another food item in that in-memory store. So it's pretty easy. Bar payload, we'll call it. We'll just make a new food item. And this food item is going to be pre-populated here. Name equals food item name. Person, food item person. Vegetarian. You guessed it, food item vegetarian. Gluten-free. So we're just going to make a payload, just make another object. Add a food item, which was our model here, so that we know everything is strict and good. We'll call this payload string. And new string content. This is where we're going to use that JSON serializer. Text. Oops. Oh, it just came up there. JSON serializer. And we're going to serialize that payload. And we need our encoding. It should be UTF-8 for this. And media type. Let's go ahead and put a media type in here. So media type names. It's going to be, application JSON. There we go. And this should, and it's pretty self-explanatory to see how this process works. We are basically creating a string out of our payload. Our payload's a food item object. We're serializing that into JSON, UTF-8 encoding, and then we're adding this media type of application JSON so that when it sends it to that Azure function, it's going to know, okay, we've got some string in the body, it's JSON, let's process it, let's work with it. We're going to await client post async, client base address, and then that payload string. Let's see if that works. Looks like it's good. Looks like there's a typo there. So if, and I'll check my chat, make sure I don't have any questions. So if response status success code, what do we do there? We're going to populate that table again. So that way it kind of feels like, you know, we've gone so far away from the page refreshing. It's just kind of nice to be able to make a call and we'll populate that table again. We'll even change the display message. Added an item. Put an exclamation point to make it exciting. Otherwise, if it comes back with something else, our display message will be response status code to string. Whoops. And you can see right there, actually, you could do some checking, too many requests, switching, you know, you can check for these and make your own kind of custom error messages for production stuff. Response status code to string should be good enough. I think I'm going to try it. I think I'm going to. So we're creating a new HTTP client, creating a new response, creating another food item object with the properties from the class that are bound up here. Then we're creating a string, serialize it into UTF, JSON, posting it async, and then looking for a request. Let's try it. Okay, food. What is our next food? Blueberry pie. We're going to say it's vegetarian. And is it going to work or is it going to spit an error? Nope, it worked. And you can see we have blueberry pie from Jeremy. Yes, it's vegetarian. False, it is not gluten-free. We add a food item, automatically refreshes, automatically in our list. Super great, awesome. So one of the things that we did have, that we still have in our API, so we're almost done with this. One of the things that we still have in our API is a delete function, right? Because I'm just putting in all this garbage in here. What about stuff that I want to delete? Let's do that real quick. Oops. All right, we're going to say private async task, call it delete food item. And this is going to need something passed into it. So all the other methods that we have didn't need anything passed in, but this is going to need an ID passed in. And you'll notice we're doing this all in C#. That's what's really cool. Like, I've written a lot of JavaScript over the years. Tons and tons of JavaScript, but I don't like writing JavaScript. I'll be honest. I like writing C#. So one of the cool things about Blazor for me is to be able to do so much stuff in C# without touching JavaScript and having it just work. It's awesome. So we're going to take this again. And those of you watching, especially experienced folks, are probably saying, holy moly, don't repeat yourself. We're repeating ourselves all over the place. We're just doing this for the stream. We could abstract all these up into a single object. We can put this into a configuration property where this right here is parameterized. There's a lot of stuff we can do, but basically right now I'm just trying to show you like Azure Functions, how cool they are. how easy it is to set one up, and then how easy it is to connect to it with Blazor. So for this response, we're going to await we want to send a delete async, because remember that function is looking for a delete command. So we want to do a delete async to the client base address. Now we have a little bit of problem here. We can't just send a delete to this address, right? If we send a delete just to the URL, it's not going to have an ID, so it's just going to either break or it's going to 404, say we can't do that. But what we can do is we can put a slash on here and say plus ID, and this will be that ID that we passed in here. So in order to run delete food item, you have to pass in an ID. And when that ID comes in, it's a string, we'll just create that URL. And this is why I designed this API this way, is because I think it makes it shorter and faster to just do everything through that single URL like this. And this can get big and complicated, and we'll be okay. So we send a delete async to that exact address. If response is static success code, what do we want to do? Well, we want a display message. We deleted ID. Else, we can do the same thing what we did down here. We could do a custom display message, or we could just response status code to string. Either way, we're going to populate the table just for the heck of it, right? So we'll await that and say populate table there. So if we delete something, or if we don't delete something, either way, we're going to get a fresh copy of what's in that database. So the last thing I need to do is add a button to delete. We'll call this action. And what I'll need to do here is put another button, bind on click again of this button. We'll make it literal. Delete food item of food item ID. All right, so food item .id. And so that's going to be the food item ID that is in the list as we're iterating. So anything that's food item.name, is a single instance within that array. So we're going to just take that food item ID out of there. So we're binding it to delete food item. I don't think I need to, don't need to do that. So on click, we're going to call delete food item and pass in that food item ID. So here's the final thing. As we wrap up here, is it going to work? I'll open up the chat room for questions. Let's see. Okay, food items. There's our food items. We got these two that we didn't like, and it deletes. We can delete all of them. Or we can add. Delete. Look how fast that is. Lightning fast, right? Because it's that Azure function that's over there just running in the background right now. And so what makes it so fast? It's a combination of Blazor, that two-way binding that we have. And somebody is sending commands to it. Bet you anything. Somebody's hitting that button right now. Or sending deletes. But yeah, so the reason this is cool, the reason this is fast, is Blazor itself is super fast. It's compiled this into WebAssembly, so I'm just shooting over stuff. Basically shooting off these HTTP client requests to a super fast Azure function, processing them, handling them. It's also fast because it's an in-memory database, right? This is not something you would actually use unless you did something in memory and then stored it back at certain times. But this is what I wanted to show. I wanted to show today how easy it is to create a function app like we did. We created this Azure Functions app, super simple, 84 lines of code. Then we created this Blazor app to communicate with it. It's roughly 135 lines of code. So what are the benefits? What's the point? I guess you could say that the point is easy development, no server configuration. We haven't configured a single server today. Easy configuration, performance. We've built something that is super performant because we have this lean and mean Azure function running. We have this lean and mean Blazor app connected to it. We're just running very lean and very minimal. Number 3, scalability. Both of these things will scale like you wouldn't believe. We can push the static app off to Azure Static Web Apps. It runs statically as HTML. The very first time you hit it, it's going to download the framework. It's going to be a little slow. After that, super fast as it interacts with the functions. So if you want easy to develop, serverless stuff, high performance, and scalable that will go anywhere, do the Azure Functions and Blazor together. And again, before I leave, before I sign off, which I'm signing off right now, Raspberry Pi could be yours. Follow me on Twitch. When I hit 500 followers, whoever has retweeted, I'm going to take the list of everyone who's retweeted that top tweet on twitter.com/Jeremy C. Morgan. If you retweet that and follow me, I'm going to take everyone who retweeted that, who follows me on Twitch. When I hit 500 followers, I'm going to give away this Raspberry Pi. I said I might give away 2 because it's taken so long to get to 500. I might give away 2. That will double your odds of winning this Raspberry Pi 400. This is a cool little self-contained computer that you just plug into a monitor, plug in a little mouse to it, and it is a fully capable computer for programming and building and IoT and all of those fun things. So thank you very much, everybody, for coming to my stream. Really appreciate it. Really excited about all of the new folks who've been following me and joining in. And I will try to get on a better schedule here soon, especially after fire season. I'm thinking in September, I should be able to hit that Monday, Tuesday, a little bit better. And I'm also going to be streaming on Pluralsight's official channel. So if you go to Twitch and you go to Pluralsight Official, I'm going to be doing streams on there. I'm going to be doing some .NET stuff. I'm going to be doing some Golang stuff. Going to be doing a whole wide variety of stuff. I'm going to do stuff that I know really well, and I'm going to do stuff that I don't know very well. And stream on both of those channels. So follow me, and thank you all. Without people watching, like all of the people that have been watching today, without people watching, there would be no reason for me to do this. So thank you, and I hope everybody has a great evening.